Hello everyone, we are discussing friction, and in friction we are discussing this profile. There are two blocks A and B. This block B is being pulled with the help of force F, and we need to decide direction of friction which is acting on B. A, for A at two places, this place as well as at this place. Now let's draw free body diagrams of A and B. Let me draw this thing over here. This is B and this is A. We're drawing forces acting on A and B. This is F. Now we know that friction opposes what? Relative motion of two surfaces which are in contact of each other. Now look here. This is F, which is pulling B over A. And this is something which is very easy also to figure out, that direction of friction which is FR1 acting on B is in this direction. B, you're pulling B east. Since you are pulling B east, friction between A and B is going to oppose this relative motion. To oppose relative motion, A exerts a frictional force on B, and this frictional force opposes F like this. So what is FR1? FR1 is force of friction on B coming from A. If you call it action, then its reaction is present on A, which is this FR1 reaction force. That's reaction force. Some of you answered this part correctly when I gave you this question as homework. Then I asked you to find friction, direction of friction between A and ground. This is A, this is ground. Now, as this A is under a force of FR1, because of this FR1, A tries to move east. Just under A is ground, and A is trying to move east because of FR1. Look at the concept. This FR1 is opposing motion of B, but same FR1 as a reaction force is supporting motion of A. This A can move only because of FR1. ऐसा क्यों? इधर सोचना. आई होप आप इतना विजुलाइज कर सकते हो कि अगर B and A इस जगह का फ्रिक्शन 0 होता, suppose there is no friction between B and A, then if you try to move B, this A cannot move at all. This A moves because there is friction present between B and A. So since we have this type of situation, friction is not zero, friction is present. So this FR1 is something which is creating motion in block A. Now with the help of this FR1, as this block A tries to move east with respect to ground underneath, ground opposes its relative motion by applying a force of friction in this direction. Let's call it FR2. So this is FR2, friction acting on A coming from ground. That's what I had asked you as the homework question. Direction of FR1, FR1, FR2 acting on A and B. Now let me see how many of you understood this part in first attempt. I will again explain this thing with the help of some other things, but in the first go, if you could understand this thing, directions, then write down yours in the comment box. And also draw the figure and the free body diagrams. Now let's understand this part again with the help of this information. Look here. This is A, this is B, and you're pulling block B in this direction. Now imagine a situation in this form. Suppose I say that this part has no friction. FR is 0 between A and ground, which can itself be a separate independent question. So friction is present between between A and B. Friction is not 0 between A and B, but friction is 0 between A and ground. for this setup, I hope it's clear that if somebody tries to pull B, this B will always move east. This B, since is under a force of F, is always going to move the velocity of B. This blue arrow is giving you that direction, that if this B moves, and I said if, what is the meaning of if? We'll learn later. There is a possibility, not in this figure, but in this, that B doesn't move. In this, it will always. And you will understand these minute differences later on. This B, since it's being pulled by F, will always move. Velocity represents motion in the direction of force. There is nothing very difficult in this part. Now imagine a situation. If you place B, अगर आप B को एक ऐसी सरफेस पर रखते जहां कोई फ्रिक्शन नहीं होता, सपोज यहां पर, तो इस B को खींचना इजी होता. लेकिन जैसे ही आपने इसको एक ऐसी जगह पर रखा जहां पर फ्रिक्शन प्रेजेंट है, तो डेफिनेटली जब आप इसे खींचेंगे तो आपको इसको खींचने में डिफिकल्टी फील होगी. हाउ डू यू प्रोड्यूस डिफिकल्टी? टू प्रोड्यूस डिफिकल्टी, you create a force which opposes your pulling force. The force which you are applying is being opposed by something, and this something is your FR1. That's how we decided direction of FR1, which is acting on B. Again, if you place B over a surface where there is no friction, then it's not difficult. You pull it, easily you can pull the object. But once you create friction, it becomes difficult. Difficulty in physics means a resistive force. So that's a resistive force, FR1. Now let's talk about A. This is A, and remember there is no friction over here between A and ground. अब मुझे इतना बताओ, and write down in the comment box, अगर मैं इस B को आगे खींच रहा हूं तो फिर ये A कहां जाएगा? इस particular situation में B is being pulled with the help of force F, then A, does it remain at rest, or it moves A, or it moves west, or anything can be possible? What is your observation for this particular setup? आपने B को आगे खींचा है, यहां फ्रिक्शन प्रेजेंट है, ये जो A ब्लॉक है, अगर यहां फ्रिक्शन नहीं होता तो आपके हिसाब से क्या हो सकता है? अगर आपको लगता है कि ये ईस्ट जाएगा, then write down east. अगर आपको लगता है वेस्ट, then write down west. अगर आपको लगता है it will not move, then write down it will not move. अगर आपको लगता है that it can move east, west, or it can remain at rest, then write down accordingly in the comment box. Good. That's a right observation. अगर आप इसको आगे खींचोगे B को, तो ये B इस A को अपने साथ कहां लेकर आएगा? आगे की तरफ. आगे मतलब ईस्ट. अब फ्री बॉडी डायग्राम्स का क्या मतलब होता है? क्यों हम प्रिफर करते हैं इस वर्ड को, इस टर्म को FBD? ये B आगे क्यों जा रहा है? बिकॉज ऑफ दिस फोर्स. लेकिन ये A, आप सबने बोला कि ये A भी कहां मूव करेगा? ईस्ट. वेलोसिटी ऑफ A. Then what is that which produces this eastward motion in block A? कोई force होना चाहिए. What is that force? It's that force which B exerts on A. This is the force which you exerted on B. But what is the force which B exerts on A? That force only produces eastward motion, and therefore this is the direction of FR1, which is this. Now आप आसानी से इस चीज को फील कर सकते हो. किस तरह से आप इजीली इस चीज को फील कर सकते हो? आपने क्या किया? आपने suppose you took imagine this is ground, this part, and there is a block, and on top of this block you place another block, say this one. I don't know if it's clearly visible. Let me take another one. I hope this is a bit clear. So this board, it represents ground. This is the top block, which is B, and then the duster, it represents A. So what is the setup? अब मैं इसे खींचने के लिए यहाँ ऊपर से फोर्स लगा दूंगा क्योंकि आगे से खींचना मेरे लिए मुश्किल है. इस टॉप ब्लॉक को जब मैंने आगे की तरफ खींचा, तो आई होप यू कैन सी दैट कि जब मैं इस ब्लॉक को आगे की तरफ खींचता हूं टॉप, तो ये डस्टर भी कहाँ आ रहा है? आगे. अब आपसे अगर पूछा जाता कि भाई ये टॉप ब्लॉक क्यों आगे जा रहा है, तो उसका रीजन क्या होता कि सर आपने इस पर आगे की तरफ फोर्स लगाया है. ये डस्टर आगे क्यों जा रहा है? मैंने डस्टर को टच नहीं किया, बट डस्टर इज ऑल्सो मूविंग ईस्ट. देन दैट फोर्स इज कमिंग फ्रॉम दिस थिंग सिंस इट इज इन कॉन्टैक्ट विद डस्टर, एंड देयरफॉर ये डस्टर भी कहां जाएगा? आगे. अब जैसे ही ये डस्टर आगे गया, ये डस्टर ग्राउंड के साथ कांटेक्ट में है. फ्रिक्शन क्या अपोज करता है? रिलेटिव मोशन बिटवीन टू सरफेसेस व्हिच आर इन कांटेक्ट ऑफ ईच अदर. सो दिस थिंग, द मोमेंट डस्टर मूव्स ईस्ट, द ग्राउंड exerts a backward force FR2 acting west. So this is the direction of FR2. Again, there is no change, but I have explained this thing with the help of a different visualization. The only thing which I expect from you, which you should not forget, is that concept of friction in the form of opposing motion of an object is not or should not be used. Friction is opposing motion of B, FR1, but FR1 is producing motion in A. In both cases, it is opposing relative motion between A and B. ये पूरा पार्ट केवल इस चीज को हाईलाइट करने के लिए है कि कैसे फ्रिक्शन रिलेटिव मोशन को अपोज करता है, मोशन को अपोज नहीं करता है. नाउ and then अगर if you find these things still a bit confusing, just don't worry. प्रैक्टिस के साथ चीजें थोड़ा थोड़ा करके डेवलप होती जाएंगी. Now write down properties of friction. Write down the first one. And the first one is the first statement of friction. Friction opposes relative motion. Friction opposes relative motion between two surfaces. Friction opposes relative motion between two surfaces that are in contact with each other. And this was the statement which we have already written. It's about relative motion. Second point, write down the statement. Friction between two surfaces. Friction between two surfaces is independent of friction between two surfaces is independent of area of contact. Friction between two surfaces is independent of area of contact. What is the meaning of area of contact? Look here. If I move this duster in this placement like this and the friction it encounters, if I move this duster instead like this, so in first case if I place it in this form, you can see the area which is in contact of the board, and if I instead move it in this form, then lesser area is in contact with the board. But statement says friction has nothing to do with area of contact. So in both cases, I'm drawing a figure and you can also do the same. So if you have a surface and you place an object like this, you place the same object instead in this form, and if you try to pull these objects with some force, same force, then in both cases, this is FR1, this is FR2. Our statement says FR1 is equal to FR2. Same object under same force, you will have same friction. Friction has nothing to do with area of contact. Now why it happens, it will be clear in just a few minutes. But before that, let's complete this part. Write down the third property. Friction between two surfaces. Friction between two surfaces depends upon cohesive and adhesive forces. friction between two surfaces depends on cohesive and adhesive forces. Let me see if you have the idea of cohesive and adhesive. Tell me, what do you mean by cohesive forces? If you have the idea of cohesive forces, then write down in the comment box. What do you mean by cohesive forces? Write down as a separate note. Mention this. Only one of you answered, but not entirely in the correct manner. What is cohesive? Cohesive means forces which act between same type of atoms, same material. Same material, the force which is present between glass and glass, wood and wood, plastic and plastic. That type of force is called cohesive. What is adhesive? Adhesive means a force which is present between different types of materials. Glass over wood, plastic over wood. So when you have different types of materials in contact of each other, then that is called adhesive force. Write down this as a separate note. Forces acting between same materials is called cohesive forces. Force which acts between same materials is called a cohesive force. For example, between wood and wood. For example, between wood and wood, glass and glass, etc. But force which is present between two different types of materials is called adhesive force. Force which is present between two different types of materials is called an adhesive force. For example, wood over glass, wood over glass, plastic over wood, etc. So what the whole thing says, friction depends upon the type of surfaces which are in contact of each other. Look, this is a plastic board, this is wood. So if you move it, the friction which is present will be different if instead I move this side and this side of duster, they are different. When I move it like this, you will experience a different friction. If I move this or if I move this, I hope you can see both are wood, and therefore this part and this part, they will experience same, but this side is different. If I move this duster over this surface, it's a different type of material, and therefore friction will be different, because friction, it depends upon what? It depends upon the intermolecular forces. Material of this object, atoms of this object, they are exerting an electrostatic force, Coulomb's force, on the electrons or the atoms of this surface. So this electrostatic interaction results in a force which is called what? Friction. So different types of materials have different types of atoms, different types of spacing, and therefore different type of or different values of frictional forces. So that's what it means when we say friction depends upon cohesive and adhesive forces. Right on, next point. Friction is a self-adjusting force. Friction is a self-adjusting force. What is the meaning of self-adjusting? You just need to wait. When it will be clear in just a while. If I am pulling the duster over the board, then depending on the force I apply, the force, friction, its value will automatically change. It will adjust its value automatically. And therefore we say that it's what? A self-adjusting force. And it will be clear in just few minutes time. So these are main and important properties of friction. And there are some elementary properties, and we'll note down those things once we need them. There is a spatial result of this cohesive force and adhesive force argument. Let's see if you can understand this. अपने को लगता है कि अगर हमने दो सरफेसेस को बहुत ज्यादा स्मूथ कर दिया, इस बॉडी और इस बॉडी की कॉन्टैक्ट सरफेस को हमने बहुत ज्यादा स्मूथ कर दिया, and extremely smooth, and then if you try to move one body over the other, तो फ्रिक्शन इंक्रीज होगा या डिक्रीज होगा? व्हाट डू यू थिंक? व्हाट इज योर ऑब्जर्वेशन? व्हाट इज योर गट फीलिंग? आई एम नॉट आस्किंग व्हाट इज द करेक्ट थिंग, आई एम जस्ट आस्किंग योर गट फीलिंग that if you smoothen two surfaces and then place them one over each other, then what do you expect? Friction to increase or decrease? So normally everybody will expect that friction will decrease. That's what the normal observation is. But in reality, it increases. So two ultra smooth surfaces means what? In normal situation, when you place two bodies like this, then at the contact face, if you use a microscope, super powerful microscope, then you will see something like this. This is body B, this is A, and similarly this is body B and A. So what the argument is कि अगर आपने दो बॉडीज को, उनके कॉन्टैक्ट सरफेस को बहुत ज्यादा स्मूथ कर दिया, तो क्या होता है उस सिचुएशन में? नॉर्मल कंडीशन में जब आपने उसको नॉर्मली स्मूथ किया हुआ है, then even then surfaces are like this. So what happens? This atom is not in contact with this atom, there is a large separation between these two. Even when you place them one on top of the other, if you look microscopically, there is a separation between this and this. These two, they are in close contact, there will be a stronger force. But not every atom is in contact with the other atom of material A. Not every atom of B is in contact with the adjacent atom of block A. This is a normal situation. But when you make these surfaces highly smooth, in highly smooth situation, this is the setup. These are the atoms and these are the atoms of A. If you somehow made them highly smooth, then once you place B on top of A, there will be a bond, perfect bond between A and B, and it will act as if you have welded A and B together. And once you weld two things, what happens you already know. So in this, which is highly smooth situation, the highly smooth situation, friction increases very much. In this situation, you will find a normal type of friction, but this is the extraordinary friction, which is as if you have welded two things. Tell me if you understand this concept of highly smooth and friction increasing or not. Yes or no? Good. Write down this as a statement also. When two highly smooth surfaces are kept in contact of each other, when two highly smooth surfaces are kept in contact of each other, instead of decreasing, friction increases. This arrow means friction increases. Inside the bracket, as if we have welded two blocks together. As if we have welded two blocks together. Now write down coefficient of friction. Coefficient of friction. Look here. We have an object of mass m. You're pulling this object in this direction with some force F. There is a force of gravity which is pulling it down. A normal reaction which is coming from ground, and you're pulling it in this direction. With respect to ground, it has a tendency to move east, and therefore friction will act west. This friction has two types of things. You calculate friction in two conditions. One is static and the other one is kinetic. बहुत इजी है, परेशान मत होना, सब कुछ क्लियर हो जाएगा once we start using numerical values. आपको अगर हल्का फुल्का कहीं भी कुछ भी डाउट होगा किसी को, तो वो भी चीज क्लियर हो जाएगी. The friction which you are applying using, it has two characteristics. One is you explain it when things are in static mode, when things are in kinetic mode. What is static and kinetic? अगर हमने, I'll explain with the help of duster on top of this. In this setup, this duster is not moving. This duster is not slipping with respect to board. It is called static condition. But in this condition, if I raise the angle, you can see that same duster is moving. That will be called kinetic. Static, kinetic. So these are the two things we are interested in. Friction is defined for static case and for kinetic, and we'll write everything in detail. अगर आप static friction की बात करते हो, then what is observed, जो static friction है, इस static friction की maximum value friction static maximum ये आया करती है, this thing is proportional to normal reaction. Observation, क्या observation है? Static condition में जो maximum है, what is the meaning of maximum, पहुंचेंगे अपन, is proportional to n. But इतने पार्ट में आपको पता है कि जब भी कहीं प्रोपोर्शनलिटी साइन आता है और हम उसको रिमूव करते हैं, then we use a constant. यही जो चीज है, F R static, S for static, max, same चीज, is equal to some constant which is called mu times n. When you remove proportionality sign, you use a constant. This constant is what? Mu. This mu is called coefficient of friction. लेकिन ये अभी किस कंडीशन में है? Static. इसलिए हमने क्या लगाया हुआ है इसके साथ s. So this mu s is static coefficient of friction. Mu s is static coefficient of friction. पूरी चीज नोट करो, परेशान मत होना, थोड़ी देर में हर चीज क्लियर हो जाएगी. लेकिन एज ऑफ नाउ राइट डाउन एवरीथिंग लाइक दिस. There are two good doubts. We'll discuss these doubts. Just note down everything on the board and then I will explain everything. एक डाउट पूछा गया है कि भाई जब आपने बोला सर स्मूथ सरफेसेस में फ्रिक्शन बढ़ जाएगा क्योंकि अच्छे से बॉन्डिंग होगी, तो फिर रफ सरफेसेस में फ्रिक्शन क्यों बढ़ जाता है? हाईली स्मूथ सरफेसेस का मतलब मैंने आपको बता दिया, अ परफेक्ट बॉन्ड which is nothing but a weld between A and B. नॉर्मल कंडीशन में जब आप ऑब्जेक्ट्स की बात करते हो तो जो नॉर्मल सिचुएशन होती है रफ सरफेसेस की, वो इस तरह की होती है. जो सरफेसेस हैं दे आर these zigzag surfaces. अब ये जब सरफेसेस एक दूसरे के कांटेक्ट में आती हैं तो जो फोर्सेस डेवलप हो रहे हैं वो किस तरह के हैं देखना. एज इफ यू हैव टू गियर्स एंड देयर teeth they are in interaction with each other. Two gears. So when you interlock these things, this interlocking takes place. Once you place this thing on top of this, because of the interlocking, this force, when you try to move this hand over the other, because of the interlocking, you feel a resistive force. Now, normal smoothing means as if you have reduced the size of the teeth in each and every gear. So if you reduce the size of the teeth, instead of this much interaction, if there is a less interaction, then you can easily slide one body over the other. But highly smooth means a perfect weld. तो नॉर्मल लाइफ में आप क्या करते हो? नॉर्मल लाइफ में जब हमने किसी बॉडी को दूसरी बॉडी के ऊपर मूव कराया, तो वहां पर इस तरह का एक इंटरलॉक डेवलप हो रहा है. अगर हम स्मूथ करते हैं नॉर्मल वे में, तो हम ये जो टीथ साइज है इसको क्या कर रहे हैं? रिड्यूस, and therefore things can easily move. But highly smooth weld. This is the first doubt. I hope clear hoga. The second one is, but then why are we not able to walk on very smooth surfaces? The second doubt कि बहुत smooth surfaces पर हम क्यों नहीं चल पा रहे हैं? I hope first lecture itself answers your question. अगर बहुत smooth सरफेस की बात नहीं हो रही, क्योंकि आप बहुत स्मूथ सरफेसेस पर आपको चलना अलाउड ही नहीं है. क्यों अलाउड नहीं है? अगर मैंने आपके शूज को वेल्ड कर दिया किसी चीज के साथ, देन देयर इज नो वे यू कैन मूव. लेकिन बहुत स्लिपरी सरफेस, बहुत स्लिपरी का मतलब होता है, नॉर्मल लाइफ में जब आप स्लिपरी बोलते हो इसका मतलब फ्रिक्शन क्या हो गया है? ऑलमोस्ट जीरो. स्लिपरी का मतलब वेल्ड नहीं है. दिस इज व्हाट एक्सट्रीम सिचुएशन, हाईली स्मूथ. तो जब आप स्लिपरी सरफेस पर मूव करते हो, एज इफ यू आर ट्राइंग टू मूव ऑन एन आइस ब्लॉक, तो वहां फ्रिक्शन क्या हो गया है? ऑलमोस्ट जीरो. और फर्स्ट लेक्चर से आपको पता है कि आपको चलने के लिए किस चीज की जरूरत होती है? फ्रिक्शन की. बिकॉज फ्रिक्शन डज नॉट अपोज मोशन ऑफ एन ऑब्जेक्ट, इट अपोजेस व्हाट? रिलेटिव मोशन. आपको याद होगा मैंने बताया था कि अगर आप आगे चलना चाहते हो, स्टार्ट करते हो जब चलना, तो फ्रिक्शन कहाँ लगता है? आगे. बिकॉज ऑफ द फ्रिक्शन ओनली यू कैन मूव. सो इफ सरफेस इज कंप्लीटली स्लिपरी, frictionless, then there is no way you can move. Let's come back for this part. Write down a few lines. When no relative motion takes place, between two surfaces, when no relative motion takes place between two surfaces that are in contact with each other, but there is a tendency to start relative motion. Relative motion है नहीं, but there is a tendency to start relative motion. Then static friction acts between these surfaces. When static friction acts between these surfaces. देखना भाई, अगेन ये स्टैटिक कंडीशन है, लेकिन अभी कोई फ्रिक्शन नहीं है, क्योंकि इसके पास कोई टेंडेंसी नहीं है मूव करने की. दिस डस्टर इज नॉट मूविंग ओवर दिस बोर्ड, विच इज कॉल्ड व्हाट? स्टैटिक. लेकिन अभी कोई फ्रिक्शन नहीं है. क्यों? क्योंकि ये चलना ही नहीं चाहता. अब आपने क्या किया? आपने इस डस्टर पर फोर्स लगाया. So if I exert a force, look, suppose this is the force. If I exert a force, this force creates a tendency, but कोई जरूरी नहीं कि आपने फोर्स लगाया बॉडी चल जाए. That's what is happening here. कि मैंने फोर्स लगाया but the body is very heavy. तो वो like बहुत heavy trunk है, आप उसको मूव करना चाहते हो, जरूरी नहीं कि वो मूव कर जाए. वैसी कंडीशन यहाँ पर है कि मैंने फोर्स लगाया लेकिन ये डस्टर मूव नहीं कर रहा है. बट व्हाट हैज डेवलप्ड बिटवीन द डस्टर एंड द बोर्ड, जो रिलेटिव मोशन है वो शुरू होने वाला है. देयर इज अ टेंडेंसी. तो अगर रिलेटिव मोशन दो बॉडीज के बीच में नहीं है लेकिन शुरू होने वाला है, तो उस वक्त जो फ्रिक्शन प्रेजेंट होगा that will be called static. In the moment your force can overcome the friction and the block starts moving. The moment you have the relative motion, ये इसके ऊपर मूव करने लगा, तुरंत क्या डेवलप होगा? Kinetic friction. So write down this. But once relative motion starts, the friction which acts is called kinetic friction. And it is observed that kinetic friction is always less than the maximum value of static friction. It is found that kinetic friction is always less than the maximum value of static friction. Look, when relative motion is present, Fr kinetic, that's all. कोई मैक्सिमम टर्म नहीं है अभी. It is proportional to n. This Fr, in short K only, when we use equal sign, we use a coefficient which will be called mu K n. So your Fr static maximum is what? Mu s n. What is mu s? Coefficient of static friction. Fr kinetic. There is no maximum with kinetic. Why? Clear हो जाएगा. Is found mu k n, and mu k you can simply write is coefficient of kinetic friction. This is coefficient of kinetic friction, and note down this, and the statement last line I said was this. आप इसी के साथ नोट करना कि जो अपना Fr काइनेटिक है, ये Fr स्टैटिक मैक्स इससे कम होता है. क्यों कम होता है? क्योंकि जो कोएफिशिएंट्स हैं वो चेंज हो जाते हैं. Why is FRK less than FR static? क्योंकि इस FRK के अंदर म्यू काइनेटिक प्रेजेंट है और FR स्टैटिक के अंदर म्यू स्टैटिक. Coefficient of static friction is always greater than the coefficient of kinetic friction. Put on this with this. और परेशान मत होना, मैंने बोला है चीज अभी क्लियर हो जाएगी. Neither. Before we go for static and kinetic, let me ask you this. This duster is on top of the board, and if I move it, I hope duster दिख रहा होगा because of the interface. So as I move this duster, which is placed on top of the board, which type of friction I am talking about? Static or kinetic? If you think it's static, write down S. If you think it's kinetic, write down K. As I move the board with duster on top, what type of friction I am dealing with? Static or kinetic? बहुत सही, good. This is not kinetic, this is static. कुछ लोगों को लगता है कि डस्टर मूव कर रहा है. Why didn't say move? Look here. Relative motion between two surfaces which are in contact with each other. This duster is in contact with the board. Board is moving, and along with the board, duster is moving. But there is no relative motion between board and the duster. It's not this. They both are moving together. तो जब तक दो बॉडीज के बीच में क्या शुरू नहीं हो जाएगा? Relative motion. जब तक दो बॉडीज एक दूसरे के ऊपर स्लिप नहीं करेंगी, तब तक हम किसकी बात करेंगे? स्टैटिक. और जैसे ही स्लिप होना शुरू हो जाएंगी, हम किसकी बात करेंगे? काइनेटिक. ये डस्टर मूव कर रहा है डेफिनेटली. किसके रिस्पेक्ट में? ग्राउंड. लेकिन अगर ये ग्राउंड के रिस्पेक्ट में मूव कर रहा है तो फ्रिक्शन अभी डेवलप नहीं होगा. फ्रिक्शन का कॉन्सेप्ट क्या बोलता है? फ्रिक्शन कब डेवलप होगा? जब दो बॉडीज आपस में कांटेक्ट में हैं. इसका ग्राउंड के साथ कोई कांटेक्ट नहीं है. Now, there is no contact of this thing, and therefore what happened? इस सिचुएशन में हम बात किसकी कर रहे हैं? स्टैटिक ओनली. लेकिन अगर ये ऐसा होता, let me place it like this, तो जब आप इसको तेजी से खींचेंगे, you can see that it slips. इस वक्त जो फ्रिक्शन डेवलप होगा, that will be called kinetic friction. Or it is observed that kinetic is always less than the maximum value of static friction. अब इस स्टैटिक और काइनेटिक की कहानी को इतना समझ लेते हैं जल्दी से, बाकी कि अपना इतना पार्ट क्लियर हो जाए. It's an important result. Don't forget to put it inside the boundary. ये जो म्यू एस म्यू के है, these coefficients, they are always less than 1. You can add this information also, that static and kinetic, it will be like 0.5, 0.6, mu 1.2. This is something not possible. Normal situation में, abnormal situations में mu 1 को क्रॉस कर सकता है, लेकिन वो जो situations हैं वो कुछ अलग तरह की हैं. जब भी हम इस तरह की चीज की बात करेंगे, म्यू आपका हमेशा क्या होगा, लेस देन 1, चाहे कोई भी म्यू हो, स्टैटिक और काइनेटिक. लेकिन स्पेशल म्यू किस तरह का, सरफेसेस को हमने क्या कर दिया, हाईली स्मूथ, विच इज काइंड ऑफ व्हाट वी हैव वेल्डेड टू थिंग्स टुगेदर. तो वहां आपका म्यू क्या हो गया, 1 के ऊपर चला गया. दूसरा एग्जांपल, जो बाइसिकल की चेन है वो गियर सिस्टम पर रन करती है, और एक सिंपल पुली की बात करें, पुली एंड रोप, देयर इज नो गियर सिस्टम प्रेजेंट. इस पुली और रोप के सिस्टम से और बाइसिकल चेन के सिस्टम से आपको दोनों म्यू का मीनिंग क्लियर हो जाएगा. एक पुली के ऊपर जो रोप है वो इजीली क्या कर सकती है, स्लिप. लेकिन जो बाइसिकल की चेन है वो गियर को तोड़ना पड़ेगा तब जाकर क्या करेगी, गियर्स पे स्लिप. द टीथ उसके साथ फिक्स है. तो दैट काइंड ऑफ मोशन विद नो स्लिपिंग कैन टेक प्लेस. वहां आपका म्यू क्या कर जाएगा, 1 से ज्यादा. वी आर नॉट इंटरेस्टेड इन दैट काइंड ऑफ म्यू. In physics, we are interested in this type of mu. So, static is always greater than mu kinetic, and these values they are always less than 1. क्या 1 से ज्यादा हो सकती हैं? स्कूल लेवल पर, नॉर्मल कंडीशन में नहीं. एक्सट्रीम कंडीशन में अब आपसे म्यू नहीं बोल रहे हैं, साइकिल और चेन का जो कॉन्सेप्ट हो जाएगा, दैट्स अ डिफरेंट थिंग. अ वेल्डेड कॉन्सेप्ट, इट्स अ डिफरेंट थिंग. तो उस तरह की म्यू की हम बात नहीं कर रहे हैं. नाउ लुक एट दिस फिगर फास्ट. बोर्ड पर देखते जाना. इट्स अ 5 kg ब्लॉक. इस तरफ एक फोर्स लगाया अपन ने, एंड दिस फोर्स इज ऑफ 2 न्यूटन्स. अपने को दिया गया दैट म्यू स्टैटिक इज 0.4, mu kinetic is 0.3. Mu kinetic is less than what? Mu static. This is 5 kg और ये अपना ग्राउंड है. पहले जस्ट मैं चेक करना चाहता हूं क्या इतनी इंफॉर्मेशन से आप मुझको फ्रिक्शन कितना लग रहा है. मैंने कुछ भी नहीं लिखा, स्टैटिक और काइनेटिक, पता ही नहीं क्या है. without my help, let me see if you can answer this. If you have a force of 2 acting on 5 kg, then what is friction acting on this block? जितनी इंफॉर्मेशन है अभी तक मैंने दी है, अगर आप आंसर नहीं दे पाएंगे तो कुछ परेशान होने की जरूरत नहीं है, क्योंकि इतनी जल्दी चीजों को आंसर देना not an easy task. But let me see if anyone out of this whole group can produce something. I'm giving you this question as homework because many of you, they say that just after 7 o'clock they have got another class. So we'll discuss this thing in the next class. I'm giving you a small hint. Small hint is what? Downward force, normal reaction force, and this is the direction of friction. This friction is of two types, static and kinetic. Static is of maximum type. Find out these values and then look at this number. Look at this number, F equals to 2. It's an interesting question. Take this question as homework. दिमाग चलेगा आपका तो फिर next class में आपके लिए समझना क्या होगा, आसान होगा. 10 minutes devote करना enough है, 10 minutes इस question को करने के लिए. And then we'll discuss this thing in the next class. Note down this much and then you can leave. Thank you.